That's me! Hello everybody and welcome to another adventure of Jackson the Space Dog. Today's topic is statistics. We'll be talking specifically about constructing and interpreting graphical displays of distributions of univariable data. What does that mean? As it turns out, that's just a fancy way of saying graphs that display information of statistical data with only one variable. Examples are weight of puppies, age of dogs, or height of dogs. And this data can be displayed in a dot plot, a stem plot, a histogram, a cumulative frequency plot, or a bar graph. Let's talk about bar graphs. If we surveyed some dogs on how many snacks they get a day, we might find we have a nice symmetric distribution. Notice the nice bell curve shape. The bulk of our data lays in the center of the graph. Or we may notice we have a left skewed distribution. That means that the bulk of our data is on the left side of our graph. We could also have a right skewed distribution, where the bulk of our data would be on, you guessed it, the right side of the graph. We also have things called outliers. And what's an outlier? An outlier is a data point that is distinctly separate from the rest of the data. Let's take a look at an example. Hey, Carl.
Oh, hey, Jackson.
If we surveyed the number of dogs in a household, we might find one that has a whole lot more dogs per household than the others do. That would be called our outlier. Outliers can cause misleading distributions in mean and range. Notice in our example how the mean comes out to be 2 and the range comes out to be 4. But if our outlier was more consistent with our other sets of data, we find our mean is only 1.57 and the range is 1. So we can see how our outlier can have a large effect on our mean and range. Thanks for watching this very brief video on statistics. See you next time on
Jackson the Space Dog!
That's Me!